I am Christine Toribio from BSED Math 2A. In this video, we will be finding volumes of solid revolutions using different methods such as the desk, washer, and shell method. In finding volumes of solid of revolutions is one of the important application of integrals in real life. A great foundation of knowledge about the properties of rules of integrals is necessary in solving for the volumes of solid of revolution. Generally, there are two methods in finding the volume of solid revolutions. First, we have the method of assigning rectangular elements in the area that are perpendicular to the axis of revolution, and the second method of assigning rectangular elements in the area that are parallel to the axis of revolution. In the first method, we have two formulas which are the desk and the washer method. The desk method is used when there is no hole or hollow part within the solid, while the washer method is used when there is a hole or hollow part within the solid. In assigning rectangular elements in the area that are parallel to the axis of revolution, we can use the shell method, which can be used whether there is or there is no hole or hollow part within solid. The problem here is to determine the volume of region bounded by the function y is equal to sine x, 0 greater than equal x greater than equal pi, and the line y equal to 0 and is revolved about the x-axis. So the region here is y is equal to sine x, 0 greater than equal x greater than equal pi, x-axis, and the axis of revolution is the x. First, make a graph or illustration of the given. Take a look at this 2D graph illustration. The first one is the red curve is r f times x is equal to sine x. The second is where x from 0 to pi, and we also have the x-axis. So we will only be getting the volume of the shaded region which we revolved about the x-axis. Looking at the 2D graph illustration above, if will it be revolved around the x-axis, we can generate a solid which is shown in the 3D figures which are generated using the GeoGebra. Looking at these figures, we can observe that it is somehow similar to some real-life figures such as a football. We are already done illustrating the region that we will be finding the volume. Now, let's evaluate the most applicable formula to be used using the illustration that we had. So, taking a look at the 3D illustration, it is already visible that when we assign rectangular elements in the area that is perpendicular to the axis, we can infer that there is no hole or hollow part within the solid. Therefore, we will use the desk method to solve for the volume. Volume using desk method. Determine the volume of the region bounded by the function y is equal sine x, 0 is greater than equal x, greater than equal pi, and the line y is equal to 0 and is revolved about the x-axis. In solving for the volume using the desk method, we have the formula. V is equals to the integral of dA a times x dx, and v is equal to integral dc a times y dy. How can we determine as to which specific formula will be used? Okay, we have 4 cases to consider in using the desk method. The first 2 cases will be for horizontal axis of revolutions, wherein the variables are in terms of x, and the last 2 cases are for vertical axis of revolution, wherein the variables in terms of y. Since we already know that our axis of revolution of the x-axis, which is horizontal, and based in our illustration, it is below the area to be revolved. Therefore, we will use the formula. V is equal to the integral of a times x dx, where a times x is equal to pi radius squared and radius is equal to the function minus axis. Let's now have another 2D illustration to label the needed values in the formula. We only need the value of r or radius, which is equal to the function minus axis. Our function above is y is equal sine x. We have sine x minus 0 is equal sine x. Therefore, r or radius is equal sine x. Let's now substitute those values in the formula. V is equal the integral wherein the lower limit is a and the upper limit is b. A times x, the differential of x, is equal to integral wherein the lower limit is 0 and the upper limit is pi. Pi sine squared x dx, wherein we need to substitute the value of a times x to the formula. So we have here pi 1 over 2 x minus 1 over 4 sine 2x pi 0. We need to factor out the pi and get the integral of sine squared x dx. So we have here pi 1 over 2 times pi minus 1 over 4 sine 2 times pi minus pi 1 over 2 times 0 minus 1 over 4 sine 2 times 0. We need to substitute the upper and the lower limit. So we have here pi 1.543435 minus 5 times 0 is, so we have here is equal to pi squared over 2 4.93 cubic units. Therefore, the volume of the solid generated is approximately 4.93 cubic units. Using the shell method, let's have another different illustration since we are using a different formula. Looking at the 2D illustration, still we have the same graph that we had earlier. The x-axis of revolution is still the x minus axis. We just have some additional information. We will find its radius and width. The radius is equal to y minus axis, so we have y minus 0 is still y. Another variable in the formula is the width. The width is equal to right function minus left function. We don't have those right and left function earlier using the dash method, so now let's make those function. Since we need our variables to be in terms of y, we will convert y is equal sine x in terms of y. So we will have x is equal sine negative 1y as our left function. X is equal sine negative 1y is only half graph since it will be bounded from negative pi over 2 to pi over 2. So we still need to find the right side of the graph. Notice that x is equal negative sine negative 1y is the same position as the half of the graph earlier. We only that we need to add pi. Therefore, we got x is equal sine negative 1y plus pi. So to solve for the volume, we have already the values. R is equal to y minus 0 is equal to y. And the width is equal to sine negative 1 plus pi minus sine negative 1y is equal to 1 is equal to negative 2 sine negative 1y plus pi. And the third is a times y is equal to 2 pi times y negative 2 sine negative 1y plus pi. Limits from 0 to 1, the limits were also changed since our variable must be in terms of y. Let's now substitute the values above in the formula. We have here v is equal the integral wherein the lower limit is c and the upper limit is d. A times y is dy. So we have here the integral wherein the lower limit is 0 and the upper limit is 1, 2 pi times y minus 2 sine negative 1y plus pi dy. We need to substitute the value of a times y in the formula. So we have here 2 pi, the integral wherein the lower limit is 0 and the upper limit is 1, y negative 2 sine negative 1y plus pi dy. We need to factor out 2 pi since it is just a constant. So we have here 2 pi, the integral wherein the lower limit is 0 and the upper limit is 1, wherein negative 2y sine negative 1y dy plus 2 pi, the integral wherein the lower limit is 0 and the upper limit is 1, pi y dy. Distribute the 2 pi and separately get the integral. So we have here negative 4 pi, the integral 1, 0, y sine negative 1, y dy plus 2 pi, the integral of 1, 0, pi y dy using scientific calculator. So we have here 1 4 pi 1 over 2 y squared sine negative 1 y minus 1 over 4 sine negative 1 y minus 1 over 2 sine 2 sine negative 1 y, and wherein the lower limit is 0 and the upper limit is 1 plus 2 pi squared 1 over 2 y squared wherein the lower limit is 0 and the upper limit is 1. We need to substitute the integral functions above. So we have here negative 4 pi 1 over 2 times 2 squared sine negative 1 times 1 minus 1 over 4 sine negative 1 times 1 minus 1 over 2 sine 2 sine negative 1 times 1 minus 0 plus 2 pi squared 1 over 2 times 2 squared minus 0. We need to substitute the upper and the lower limit and last equation. So we have here negative 4 pi minus pi over 8 plus 2 pi squared times 1 over 2. So we will have here negative pi squared over 2 plus pi squared. So we have here 5 squared over 2, 4.93 cubic units. Therefore, the volume of solid generated is approximately 4.93 cubic units. Using the shell method, we also got the same answer as what we had using the dash method. Therefore, the volume of the solid is generated is approximately by 4.93 cubic units. Revolving a graph around an axis results in the formation of a solid. Transforming a two-dimensional representation into three-dimensional one. By analyzing the measurement of the graph, the volume of the generated solid can be determined using established mathematical formulas or methods. Over time, various methods for calculating the volumes of solids have been developed, providing essential tools for accurately measuring larger structure encountered in real-world scenarios. These discoveries play a crucial role in different fields such as engineering, physics, and architecture. Understanding these methods make it easier to compute exact measurement, contributing to mathematical technological advancement.